All right, so for number 3, usually if we have a fraction like this, like we have a couple of options. The first thing that you always want to try and do is simplify the fraction if you can. So when I see this, I recognize x squared minus 1 is the difference of two squares. So this is basically the integral from 1 to 2. I'll show you the middle step here, but this is going to be x plus 1, x minus 1, all over x plus 1 dx. Okay, so that's the first thing you want to look for, is to see if you can simplify it, because if it does, it makes the integral much, much simpler to do. Okay, so the x plus 1's just cancel out, right? Are you good with that? Yeah. So now we're looking at a pretty simple antiderivative. We have the integral from 1 to 2 of x minus 1 dx. The only other option would be if we had something that its derivative was also there. So let me finish this one and then I'll see if I can make up an example, which I'm usually not good at making up examples on the spot with these problems because I usually make a mistake, but maybe we can get the idea across anyway. So since this is a definite integral, we got numbers on the integral. We don't really need to worry about the plus c. So we're just going to do our antiderivative, leave out the plus c. So antiderivative of x is going to be add 1 to the exponent, so x squared, and then divide by that number, minus the antiderivative or integral of 1 is just x. And we're going to evaluate this from 1 to 2. So let me actually get rid of this equal sign, move it over a little bit, just so I can make sure I don't run out of space. So plug 2 in, so we get 2 squared over 2 is 2, minus 2. There's our first part. And then minus, plug 1 in, we get 1 squared is 1 over 2, so 1/2. Don't forget to put this in parentheses, because a lot of times people forget to distribute the negative there, and you end up with a messed up problem. And then plug 1 in for x, and we get 1. So this is what you get when you plug 2 in. 2 squared over 2 gives you 2, and then minus 2, so that's a 0. And then this is what you get when you plug 1 in. 1 squared is 1 over 2 is 1/2 minus 1. Okay, so final answer here, 1/2 minus 1 is negative 1/2. The negative out front gives us a positive 1/2. Okay, you good with that one? All right, now the other type of problem that I was talking about, like let's say if we have an integral, whatever, you can have numbers here if you want. We can still say 1 to 2. But then let's say if we have something like, I don't know, x to the third minus 2x, and then your top is 3x squared minus 2. You see how like the derivative is in the numerator. So then when we do this, you can say that u is equal to x cubed minus 2x, and then, or even better, it would be, because you can't do the derivative, you can't do the antiderivative of 1 over u yet. That's not something we've learned. So let's say if we have something like that, then we say u is equal to this x cubed minus 2x. When you do your derivative, du, you get 3x squared minus 2 dx, which we know we have that in the numerator up here, right? We have that right here. So we can do this by saying integral from 1 to 2 of 1 over u squared du. Right? Then we can do that, add 1, so you get u to the negative 1 over negative 1, and kind of go from there, right? So that's pretty much the only options that we have with fractions for now. I was going to add in the inverse trig function antiderivatives and logarithms and stuff in here, but there's already so much stuff in here that I was like, I'm not adding anymore. I think we're good for unit 6. Like, we'll just get this test out of the way. I'll put another test in here, going over the logarithms, and the antiderivative for the trig functions, and you know, that'll be a separate thing, because I can't put any more in this test. There's already a lot of stuff in here. I'm already finding it difficult to narrow down the test to 2 days worth of stuff. They're not bad, it's just a lot of information, which I know that in itself can already be like overwhelming. But yeah. So these type of problems here, these are this one and the next one, straight from AP problems, okay? So it might look a little confusing, you know, to start it off with, but we know what this is telling us to do, right? So we're just going to treat k as if it's a number, okay? Common mistake, a lot of people want to do k squared over 2 when you do the integral, right? But this right here is telling us we're only integrating the x stuff. Anything else that's not an x is a constant. So whether it's k or a or b or c or d or any other letter, those are considered constants compared to this right here, which tells us we're differentiating with respect to x. Or integrating, sorry. Integrating with respect to x. So let's do that. So x to the 7th becomes what? Add 1, divide by that number. You want to take a stab at this one? Kx, that's it. And we're going to evaluate this from -2 to 2. So let's plug 2 in. 2 to the 8th. 2 to the 8th is something. I think that whole thing becomes 2 to the 5th, which is 32. Plus 2k. Minus. -2 is going to be the same thing. Is that right? Did I do that right? Because this would be x to the 8th. So this is like 2 to the 8th, right? If I'm plugging 2 in. And then 8 is 2 to the 3rd. So that's 2 to the 5th. Is that 32? 2, 4, 8, 16, 32. Yeah. And then minus 2k. Are you with me? Good? All right. So 2k minus -2k is 4k. And what do we know this is equal to? 16. So now k is 4. Which, this was a multiple choice question. I just got rid of the multiple choices. So.
I did not take k as a constant. I took the, like, x.
You did the k, you fell for it. Yep. Yep. Yeah, and it happens. I mean, that's why they do that. They're like, let's see who's not paying attention. And really, I mean, that's what we got to remember, is that this right here tells us which of these is a variable and which of these is a constant. Because they're all letters, right? But letters are different. Some letters are variables and some letters are constants. So that's why we look to this right here, and that tells us x is the variable, k is the constant. Okay, are we good with that one? All right. So, let me...
Please excuse the interruption. At this time, all students who are on the bocce ball team should be dismissed. Students on the bocce ball team should be dismissed. And students, you will go to the main lobby by the big front doors. Your coaches will meet you there.
Okay, so if little f is an antiderivative of this function, such that f of 1 equals 0, then f of 4 equals what? You ready? Okay, so antiderivative, we're going to look at our integral, and we're going to go from 1 to 4 because that's the x coordinates that we have here. Okay? Of this function x squared over 1 plus x to the fifth dx. Okay? Good? So this is equal to f of 4 minus f of 1 by the fundamental theorem of calculus, right? So because this is, if we're doing this, that's equal to the antiderivative, which we're told up here is little f. So that's equal to f of 4 minus f of 1, right? We're trying to solve for f of 4. So f of 4 is equal to f of 1, which is a waste of writing because f of 1 is 0, so that does nothing, plus this antiderivative here going from 1 to 4 of x squared over 1 plus x to the fifth dx. Okay? So, let's try and do this with u substitution. Now, I know when we're first looking at this, we're going to say, well, if we set u equal to like 1 plus x to the fifth, then we do du is equal to 5x to the fourth dx. And I think this was another multiple choice question. And the answer may have just been written like this, because either that or this is one that we need to use one of the antiderivatives that we haven't covered yet, because, like I said, I moved some stuff around this year. So, because if we solve, that's not going to work. No, because if we do it the other way, we're going to need logarithm. So that way it didn't get us anywhere. If we set x squared equal to u, then we would have du is equal to is that going to work? Maybe. 2x dx. So like if we do f of 4 is equal to, we can get rid of f of 0 because or f of 1 because that's equal to 0. So that's not going to change anything. So if we do this, now this is something I was trying to think, I don't know if I covered this in any of the notes or not, but if I know u is equal to x squared, like this is the same thing as 1 plus x squared raised to the 5 halves, right? So we can replace that with u and have 1 plus u to the 5 halves. But the problem there is that's also an antiderivative that we can't do, because then we would end up with u over 1 plus, like I said, u to the 5 halves du, which again is not an antiderivative that we can do. So I think I may have jumped the gun a little bit on this problem, because I think that's something that we'll cover later on. But I don't think this is, just trying to think of other options. I don't think there's a way that we can, because we can't split it up. You know, if this was the reciprocal, if we had 1 plus x to the fifth over x squared, we could split it up, 1 over x squared, and then x plus x to the third. So I'm trying to think. I know this one used to be a multiple choice problem, and I'm wondering if the answer was just written like this, because this antiderivative is not something that we can do yet. This one right here. So that may have been the way that the answer was written, because we just tried both possible options for.
Attention students, the bocce ball team is ready to leave. Ryan Berry, Cooper Irving, Carmere Tilford, Kaylee Heller, please report to the main lobby.
Trying both of the options for u doesn't get us anywhere. So I should probably look up that problem again and see how the answers were written, because either way we did that, it wasn't really going to work. So, yeah, I'm just trying to think if there's any other option that we have, but I don't think there is. Unless it was a calculator problem, which it may have been. And if it's a calculator problem, then you just plug it in your calculator. That might be what it was. It may have been a calculator problem. So we could just plug this integral into our calculator and get 3 decimal places. But that's probably what it was. So maybe I'll add that to my directions for next year. So yeah, I would say that's probably the only option that we have there. So I'm gonna plug it in and see what we get. So let's get rid of this here. Does it repeat or anything like that, or is it? Will it change it to a fraction? You do math fraction. If it won't change it to a fraction, then I'm going to say it's something that we can't do by hand. Yeah. So that must have been a calculator problem. So f of 4 is approximately 0.376. Okay? Are you good with that one?